Everyone, today we're gonna talk about metal. By our group, have you ever seen metal around yourself? Yeah, it is around ourselves, and this is the one of the metal. It is iron, and it's not our content today. We know that we have many kind of element in the periodic table and many kind of metal in periodic table same. But today we're gonna focus at these metal. This metal name holds transition metal. And what is it? What is the definition of it? So the definition of post-transition metal is the group of the metallic element found in the periodic table specifically located between the transition metal and the metalloid. They are characterized by their position in the D block of the periodic table. And this is them again. And why these metal are post-transition metal? Is about the properties. Their property is not the transition metal and is not the metalloid. The first one is the variable reactivity. Second is multiple oxidation state. Third is malleability and ductility. Fourth is good conductivity. Fifth is colorful compounds. Sixth, formation of the complexes. 7. Softness. And 8. Density and variability. First, variable reactivity.
Variable reactivity. The reactivity of an element depends on its electron configuration and the ease with which it can lose or gain electrons to form ions. Post-transition metals have electron configurations that make them less likely to form ions compared to alkali and alkali earth metals. This is because they have relatively stable electron configurations due to the filling of d orbitals. Post-transition metals tend to form covalent bonds rather than ionic bonds. Covalent bonds involve sharing of electrons between atoms, which result in molecules rather than ions. Multiple oxidation states. The ability of post-transition metals to exist in multiple oxidation states is due to the availability of electrons in their d orbitals. These metals can lose different numbers of electrons to form ions with various charges. This is because the availability of d orbitals allow post-transition metals to participate in electron transfer reactions, leading to the formation of different oxidation states in compounds. Malleability and ductility are properties that arise from the ability of atoms to slide past each other without breaking bonds. In post-transition metals, the presence of relatively weak metallic bonds allows for easy formation without bond rupture. Because post-transition metals typically have metallic bonding, where metal atoms share their valence electrons in a sea of delocalized electrons. This bonding type allows for movement of atoms without significant bond disruption. Good conductivity. This is also because of metallic bonding that post-transition metals typically have due to the presence of loosely bound valence electrons. And good electrical and thermal conductivity in metals arises from the presence of delocalized electrons that can move freely to the metal in response to an electric field or temperature gradient. Colorful compounds. The Volapant colors observed in some post-transition metal compounds are due to electronic transition between different energy levels of d orbitals. These transitions result in the absorption and emission of light of the specific wavelength. For bonding or involved in this, complexes formed by post-transition metals often involve coordination compounds where ligand donate electron pairs to metal ion. The interaction between the metal ion and ligands give rise to different energy levels for d orbitals, leading to color compounds.
Next is formation of complex. It's a post-transition metal readily form coordination complex due to their ability to accept electron pair from ligand. This result is in the formation of stable complex with distinctive chemical properties. About the bonding, it coordinate complex involve the coordination of central metal ion with surrounding ligand through coordinate covalent bond. Post-transition metal can accommodate ligand into the orbital leading to the formation of stable complex. Softness. Softness is the post-transition metal is often attributed to the presence of weak metallic bond and relatively large atomic size. These factors allow for the easy movement of atoms, resulting in low hardness bonding. Knowledge is a weak metallic bond in post-transition metal contribute to their softness. These bonds are characterized by sharing of valence electron among the metal atoms. Density variability in the post-transition metal arises from difference in atomic size and packing efficiently. Metal with larger atomic size and low atomic mass tend to have lower density. About the bonding knowledge of density is influenced by both atomic mass and atomic packing. Post-transition metal can exhibit different density depending on their atomic property and crystal structure. Understanding the atomic structure and bonding characteristic of post-transition metal helps explain their unique property and behavior of various chemical and physical contexts.
Pigments and dyes. Post-transition metal compounds are utilized as pigments and dyes in industries such as paints, ceramics, and textiles due to their vibrant colors. For example, titanium dioxide is a common white pigment, while cobalt compounds are used to produce blue pigments. Alloys and metallurgy. Post-transition metals are often alloyed with other elements to improve mechanical properties such as strength, hardness, and corrosion resistance. For instance, copper-zinc alloys or brasses and copper-tin alloys or bronzes are widely used in various engineering applications. Soldering alloys. Post-transition metals like tin and lead are commonly used in soldering alloys due to their low melting points and ability to form strong bonds with other metals. These alloys are essential in electronics manufacturing for joining components on circuit boards. Catalysis. Certain post-transition metals such as palladium and platinum are widely used as catalysts in chemical reactions. They facilitate reactions by providing an alternative pathway with lower activation energy, thus increasing reaction rates and selectivity.
Thermoelectric material. Some post-transition metal compounds exhibit thermoelectric properties, meaning they can convert heat energy into electrical energy and vice versa. These materials are employed in thermoelectric energy generator for waste heat recovery and portable power generation. Glass manufacturing. Post-transition metals like boron and aluminum are used in the production of glass to modify its property. Boron is added to the borosilicate glass to increase its resistance to thermal shock, while aluminum is used as a fining agent to remove bubbles from molten glass. Next is battery technology. Post-transition metals like zinc, cadmium, and mercury are used in the battery due to their ability to undergo reversible redox reaction. Zinc carbon batteries, nickel cadmium batteries, and silver oxide batteries are symbol of battery utilizing post-transition metals. Catalytic converter. Post-transition metals such as platinum, palladium, and rhodium are essential components of catalytic converter in automobiles. They help convert harmful pollutants in exhaust gases such as carbon monoxide, nitrogen oxide, and hydrocarbon into less harmful substances. To summary, this application demonstrates the versatility and importance of post-transition metal across various industries, from electronics and manufacturing to environmental protection and energy storage.